Hi, this is Anisha Datta. Currently, I am pursuing MTech in the branch of Computer Engineering from NIT Kurukshetra. The project that was assigned to me was to build a big data pipeline. Here are the contents. Now, what is big data? It is a collection of data that is huge in volume yet growing exponentially with time. It deals with terabytes and petabytes of data. Now, we'll see what is big data pipeline. It can be described as subsets of ETL solutions. Like typical ETL solutions, they can work with semi-structured, structured, and unstructured data. The flexibility allows you to extract data from technically any source. Big data pipelines can also leverage the same transformations and load data into various repositories, including data lakes, relational databases, and data warehouses. It can process data in streams, batches, or other methods. Like in streaming data pipeline, it works with data moving on to further processing and storage from the moment it's generated. For instance, a live data feed. The stream processing engine can provide outputs from the data pipeline to data stores and marketing applications. In case of batch data pipeline, here you simply collect data fragments in temporary storage and send them as a group on a schedule. To run a big data pipeline seamlessly, here are the three components you will need: compute, messaging, and storage. The compute component allows your data to get processed, like for example Apache Flink, Apache Spark, Hadoop MapReduce, etc. For case of messaging components, which are used to migrate events or knowledge from point A to point B in real time. For example, Apache Pulsar, Apache Kafka. And in the case of storage components, they are responsible for the permanent persistence of your data, like cloud file systems like Amazon S3, HDFS, local storage. Here is the architecture of big data pipeline, which consists of 5 stages. In the first stage, we collect data from various data sources like mobile apps, microservices, IoT devices, etc. Then data integration or ingestion is happened with the help of ETL process or stream data integration. Then it is stored on data warehouse, data lakes, etc. and then processed to analyze and with the help of analytics algorithm, machine learning algorithm, and then we'll get the output as in the form of reports, microservices, push notifications, etc. Now we'll see what is ETL process. It is abbreviation for extract, transform and load, which is the process of combining data from multiple sources into a large central repository called a data warehouse. ETL uses a set of business rules to clean and organize raw data and prepare it for storage, data analytics, and machine learning. You can address specific business intelligence needs through data analytics, such as predicting the outcome of business decisions, generating reports and dashboards, reducing operational inefficiency, and more. It works by moving data from the source system to the destination system at periodic intervals. The ETL process works in 3 steps. For the first step, it extracts the relevant data from the source database. Then it transforms the data so that it is better suited for analytics, and then it loads the data into the target database. In data extraction, ETL tools extract or copy raw data from multiple sources and store it in a staging area. In data transformation, ETL tools transform and consolidate the raw data in the staging area to prepare it for the target data warehouse. It involves some types of data changes like data cleansing, data deduplication, joining, encryption, etc. And in the data loading phase, ETL tools move the transformed data from the staging area into the target data warehouse. So here is the graphical representation of the ETL process. Now we'll see what tools we have used in the project. We have used Python version 3.5 or higher can be used here. Then Amazon S3 is used here, which is Amazon Simple Storage Service. that is an object storage service offering industry-leading scalability, data availability, security, and performance. Customers of all sizes and industries can store and protect any amount of data for virtually any use case, such as data lakes, cloud-native applications, and mobile apps. Next one is Apache Airflow. Here is the architecture of Apache Airflow. It is a workflow engine that will easily schedule and run your complex data pipelines. It will make sure that each task of your data pipeline will get executed in the correct order and each task gets the required resources. The components of Apache Airflow are DAG or Directed Acyclic Graph, that is a collection of all the tasks that you want to run, which is organized and shows the relationship between different tasks. It is defined in a Python script. Next one is web server, which is the user interface built on the Flask. Next one is metadata database. It stores the status of all the tasks in a database. Next, scheduler, which is responsible for scheduling the execution of DAGs. Now we'll see the code here. So first we have installed all the packages like Apache Airflow, Amazon S3 and TweetPy for fetching the Twitter data. Then we'll import these libraries. Next, we have used a function where it will store the Twitter data using some keys and it goes through some authentication phase. Here we want to use the tweets from the user Elon Musk and we'll set the count as 200 and then it is returned in the form of JSON format where the user is the username, the text contains the tweets, the favorite count is the likes, number of likes, the retweet count is the number of retweets, etc. And then we want to convert the JSON format into data frame and to CSV file. Next, we have imported the Airflow function, Airflow module, Python operator, datetime module, etc. Here is the default arguments where owner is the owner name of the workflow. Here it is Airflow. Depends on past means if each time you run your workflow, the data depends upon the past run, then mark it as true, otherwise mark it as false. Then the start date of your workflow, email ID and retry delay. If any task fails, then how much time it will wait to retry it. Then the DAG components are here. It is the DAG name and the other components are used here with the description also. Then we'll run the run ETL function and then we'll get this result. The tweets of Elon Musk user are stored in the S3 service. So this is the project of data pipeline, which is to fetch Twitter data from using the Twitter API. Then we get the processing done on the dataset and then it is stored on the Amazon S3 service. So this is it. Thank you.